In this lesson, we're going to look at special products. So when multiplying polynomials, you'll find that certain types of polynomials that when we multiply them together, they will have a pattern in the product that they produce. So we're going to look at those special scenarios today. So firstly, whenever we're raising a polynomial to a power, we will need to make sure to simplify something like this a certain way. So when a polynomial such as x minus 1 cubed is raised to an exponent, you can rewrite the problem in long form and then multiply the polynomials normally. What you should not do is look at this exponent of 3 and say, oh, that applies to all the exponents inside. You cannot do that because there is this subtraction sign in between. Distributing that exponent worked when we had something like this, which was a monomial, and the 3 would apply to every exponent inside. Because we are dealing with polynomials, you must stretch it out. So when in doubt, stretch it out. So x minus 1 cubed really means x minus 1 times itself 3 times. So everyone has to stretch this out to mean x minus 1 times x minus 1 times x minus 1. We need to write it 3 times. Once you've done this, this is just an example of multiplying more than 2 polynomials together. And when we do that, we focus on the first 2 using our arrows to multiply out, staying organized, and then we bring down the last x minus 1 once we multiply the first 2. So let's go ahead and do that. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative 1x, and negative 1 times negative 1 is positive 1. So that is what I now have. Remember to keep parentheses around what you get and to bring down that x minus 1. We have not used it yet, so you got to keep bringing it down. Now you may notice inside that these two terms, negative x minus x, will combine because they are like terms. They're the same variable to the same exponent. So I would recommend simplifying inside that parentheses first. So combine those to be a negative 2x. Keeping that entire first polynomial in parentheses, we now will multiply what we have there by that final x minus 1. So again, let's use our arrows. X squared times x. Oh, there's going to be some combining. Anyways, x squared times x is x cubed. X squared times negative 1 is negative x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is plus 2x. 1 times x, the last term to multiply through, is x, and 1 times negative 1 is minus 1. So here you will see all of that multiplying written out as one long expression. Finally, the last step in these types of problems is to combine your like terms. So the x squared terms will combine and the x to the first terms will combine to give a negative 3x squared and a positive 3x to the first. This is your final expression for x minus 1 cubed. So the big takeaway is that you have to stretch these out. There is one for you to practice on your own, 2x plus 3 cubed. I'd like for you to work this one out. So pause the video. When you're ready to come back and check it, you can click play. Okay, so at this time, you have worked this problem out. Everyone should have started by stretching that 2x plus 3 out cubed. So 3 times we should have 2x plus 3 times 2x plus 3 times 2x plus 3. In your first step, focus on just multiplying the first 2 binomials. That should have produced, when we simplified, a 4x squared plus 12x plus 9. Making sure to bring that 2x plus 3 down with our work, even though we haven't done anything with it yet. From there, you multiply these last 2 together. We should have lots of arrows here. to get this long stretched out polynomial, and finally combine your like terms. So this is what you should have ended with. All right. Let's move on to now look at some special products. So the first one we're going to look at is a binomial square. A binomial square, such as x plus 5 squared, has its own pattern. So just like the binomials cubed we were just looking at, you must stretch this out to multiply an x plus 5 squared. So that is x plus 5 times x plus 5. So we all need to stretch this out. Take a moment and multiply this out, and then see if you make an observation about anything interesting that you get with your first and your last and middle terms that you'll get from this multiplying. So work it out and then click play when you're ready to check. Okay, so you should have stretched this out to get an x squared plus 10x plus 25. And only having done one of these, you may not notice anything crazy special right from the beginning. So maybe let's take a look at a second one. Let's say we did x plus 3 squared, which is x plus 3 times x plus 3. So we'll multiply those to be x squared plus 3x plus 3x plus 9. So that simplifies to an x squared plus 6x plus 9. So now that we've done two of them, or you can see, I hope you noticed that every time you stretch out one of these binomials by itself, we get this same thing in our middle two terms before combining. And that is no coincidence. We could do that with another set. We could do it with, let's say, subtraction. X minus 2 squared would look like x minus 2 times x minus 2, which is x squared minus 2x minus 2x plus 4. Again, the same two things, two terms in the middle. So that is hopefully one observation that you can now see. Also notice these are all x squareds in the first term. And that is no coincidence either. That first term always comes from multiplying whatever is in the first slot. So in that scenario, if x is in the first slot, I'm going to always, when I stretch it out, multiply it by itself. So x times x is x squared. Now I used x for all of these. Let's say we used a 2x plus 1, and we squared that. Well, 2x plus 1 times 2x plus 1 has us multiplying 2x times itself in the first step, giving a 4x squared. So that first term is always going to come from whatever is in the first spot in the binomial and squaring itself. Similarly, the last term always comes from whatever the number is in that last spot of the binomial. And you'll see we always end up doing the 5 times the 5, that same number times itself in our last multiplication. So to get this last term, the 5 we will square. So there is this pattern. So let's get the rules filled out for how to, oh, did I go backwards? Oh, here we go. For how to anticipate what the pieces of our polynomial answer will be once we've multiplied it out. When we square a binomial, so a binomial times a binomial, we will end up, or towards that times that same exact binomial, we will end up with a trinomial. So a binomial square, taking a binomial and squaring it, always makes a trinomial, such that the first term comes from whatever was in that first part and squaring it. So that's x squared in this case, because the first part here was an x, so we square it to get x squared. The second term comes from twice the product of the two parts. So a way to get that part that always repeats here in the middle, that 3x repeating, is to take the x, which is the first part, then take the positive 3, which is the second, multiply them together, and then double it. So it's twice the product of the two parts, 6x in this case. And the third term is always equal to whatever the second part was squared. So the second part was a 3. We square it to get the 9. And I realized I thought that we had already done it, done the x plus 3 squared. This one was not the same as the last slide, so I apologize for rushing straight to the rules for this. Giving us that x squared plus 6x plus 9. So if you can identify the pattern and what happens with each of the parts of the binomial when we square a binomial, then you can actually jump straight from x plus 3 squared to the x squared plus 6x plus 9 without having to stretch it out and do all of the this stuff in the middle here. Now, obviously, you only need to use this if you're comfortable with it, or you only need to really, you don't have to always use this shortcut or this method, but it will definitely help us in our next unit if you can become familiar with these patterns that we're finding here in this unit. So let's practice applying this. We have y minus 2 squared. This is a binomial squared. So this means that to stretch it out, we would be able to use the rules that we just found about the 3 pieces. We know it's going to create a trinomial. And to get our trinomial, we're going to start by taking whatever was in the first part and squaring it. I like to do my ends first, so then we could take the 2 and square that, and then I like to finish with the middle part because the ends will always be squared from whatever the parts were in the binomial. Lastly, to get this middle part, I want you to notice that this is a negative 2. When we square it, it doesn't matter because it will always end up as positive. But our parts are a y and a negative 2. So for the middle term, we will take them and multiply them together, giving us a negative 2y, and then you double that. So doubling it gives us negative 4y, meaning the middle term should be negative 4y. Now this 4 at the end was positive because anything times itself is positive. So you do just need to pay attention to this sign. This sign will always match the middle term's sign. Let's try another one. Here we have 3x plus 1 squared. So to stretch this out or get the trinomial that this will multiply out to give us, we'll take the first term and we square it. 3x times itself is 9x squared. A positive 1 squared is positive 1 still. And the middle term, we take 3x and 1 and multiply them to get 3x, and then we double it to get 6x. So that is a plus 6x in the middle because they're positive. Lastly, we have a 2n minus 4 squared. Take your first part, square it. Take your second part, square that. And the middle piece comes from multiplying 2n times negative 4, which is a negative 8n, and then doubling it to get negative 16n. So the middle term should be negative 16n. So hopefully you're able to now pick up on this pattern. Like I said, when in doubt, you can always stretch these out and go about them the long method. However, I would like for you to push yourself, especially on the homework practicing this, to use this method to get your trinomials. I do want you to also notice that we start out with something short in length and end by widening out and ending with a trinomial. The reason I'm pointing this out is because the next pattern we're going to learn, you will see us start out with something longer and it shortens up to something shorter. So that's a way that I remember that binomial squared should end up with something in the middle, a third term, a trinomial. It should get wider and longer as you stretch these out, whereas this next pattern actually shortens up. So the next pattern we're going to look at is the product of identical sums and differences. So the product of a sum and difference such as h plus 4 times h minus 4 will have its own pattern. So you can recognize a problem like this because the parts of the binomials should match each other. The first parts are both h's, the second parts are both 4's. The only thing is their signs are different. So if you notice this, they will also have a certain pattern. Go ahead, multiply that out. So you should get h times h to be h squared, h times negative 4 to be negative 4h, 4 times h to be plus 4h, and 4 times negative 4 to be negative 16. Now that we looked at that last method, you might already start to notice kind of some similarities. The first term that we're getting is the square of that first term. The last term we're getting, 16, is 4 squared. So there are some similarities. However, we haven't fully simplified yet. In the middle, the difference is this one gives a minus 4h and the other one's a plus 4h, meaning that when you combine these like terms, they go away. They cancel each other out. They become 0. Negative 4h plus 4h is 0. And you're only left with h squared minus 16. Do pay attention to the minus. Oops, there we go. So we started out with two binomials that were almost identical except their signs were different, and we ended up with a binomial that was the squares of the parts. So let's try this again with x minus 3 times x plus 3 to see if we notice similar patterns here. So stretching this out, we will multiply x times x to get x squared, x times 3 to get 3x, negative 3 times x to get negative 3x, and negative 3 times positive 3 to be negative 9. Once again, our middle two terms simplify to 0, going away, leaving us with x squared minus 9. So notice we started with something stretched out, and we shortened down to something much smaller, just a binomial. So multiplying a product of a sum and difference always creates a binomial with a subtraction sign in the middle. The reason it's always a subtraction sign in the middle is because to get that last term, you were always multiplying one negative times one positive. Now the number comes from just looking at the 3 and squaring it. But so these always come with a subtraction sign in the middle. So the rule is that the first term will be whatever the first part of those binomials is, the x squared. And the second term is always the second part. One's positive, one's negative, but we're just going to focus on the number 3 squared to get the 9. And there is always a subtraction sign in the middle. Always, always, always. That's a rule you can memorize. This also has, the x squared minus 9 has a special name called a difference of squares. The reason this answer is called a difference of squares is because it is the difference, there's the minus, of two perfect squares. X squared is a perfect squared and 9 is a perfect square. So because it always produces subtraction in the middle and two perfect squares on the ends, we can also refer to this as a difference of squares, which we will get into more in our factoring unit. But let's practice this. So remember, with these problems, we start out longer. We should shorten down when we apply the shortcuts here. So we have the exact same binomials with different signs, so we can use our shortcut. Take the first term, square it. Take the last term, square it. Oops, which is 25, not 5. And put a minus in the middle, and you're done. Why don't you try the next two on your own? Click pause when you're ready to check. Click play. Okay, so we get, for this one, 4x squared minus 9. And for the last one, 6n times 6n is 36n squared. And 4 times 4 is 16 with a minus in the middle. Again, subtraction sign in the middle every single time. When in doubt, stretch it out, work it out the long way by all means. However, if you can recognize this relationship, I do encourage you to use the pattern. So we will not do that. We are done with this lesson, and you can work on your homework if that is where we are in class.